Okay, so today we're going to be working on the quadratic formula practice assignment. So this is a little more extra practice for you guys. I gave the answers to the odd problems, so I'll be working on the even ones on this assignment for this video. If you look to Google Classroom, you can find some of the answers. So here I figured I would help you guys get through the even ones. So if you're focused and you're motivated, you should be able to get some good practice done. So let's start off by looking at all of our steps. Okay, the first step, of course, you should have in your notebook is that we want to set the equation equal to 0. But this equation is already set equal to 0, in which case we don't have to do that. But we move on to the next step where we have to copy the formula. So now what we will do is we will take n and we will use the quadratic formula. We'll do the step where we have to copy the formula. Okay, so you recognize that you need to use it. In this case, the assignment is telling you to solve these by using the formula, so you copy it. The next thing that you would do would be to identify A, B, and C. Okay, so we have A, B, and C, and we'll identify what these values are. Okay, A would be 6, B is negative 11, and then C is negative 52. So the next thing that we're going to do is add a bunch of blank parentheses. Okay, and then we'll put those values in there in a second. But we change every letter into a blank parentheses. So the good news about the quadratic formula problems is that they're kind of all the same, aside from the first step where you have to set everything equal to 0. And the simplification might be a little different, but everything else is basically the same, right? The setup all starts the same way. So the first number we will plug in will be negative 11, in this case for B. Then for this blank, we'll put negative 11 also. So B goes into both of those. We'll plug in A, and then C is negative 52, so we'll put that here. Okay, and again, A is 6, so we'll put 2 times 6 right here. So now in this next step, we're going to simplify these values, and negative 11 means positive 11. So now we'll do plus or minus, and what we'll do is simplify the rest of these values, right? Negative 11 squared is negative 11 times negative 11, and that makes 121. So what I have everybody do is leave one blank parentheses there, and in that spot we'll put the value of 4AC. So we'll go calculate that in a second. First what we'll do is put 2 times 6 here, and that's 12. So that's what we get in this location right here. We have 2 times 6 is 12. So I've been getting plenty of questions about this. Why aren't we treating the 4 like a negative? And you could do that. You could treat the 4 like a negative and multiply through, but what happens is when you leave out this step, eventually you're going to probably mess up a negative, and then when you go back and try to check your work, it's kind of hard to tell whether or not you made a mistake, right? So, you want to make sure that you recognize that this number is always going to be positive after we square it, right? If we square a negative number or a positive number, we're going to end up with a positive number every time, right? Because a negative times a negative is also positive. So in this parentheses, right, in between these two parentheses right here, we might have something that is negative, or we might have something that's positive. And because we're subtracting a negative, we want to be able to see that. We want to be able to see that we have minus a negative so that we can make sure that we double check and changed it, right? So think about what goes in this parentheses is 4AC. Okay, so 4AC, what does that mean? That means multiply 4 times A and then times C. So that means I have to do 4 times A, and A is 6. 4 times 6 is 24. And then we'd have to do 24 times 52, times negative 52. So 24 times negative 52 makes negative 1,248. So the value that I should go put in this parentheses, right, is 4AC. And 4AC is negative 1248, so that's what I'm going to write here. Okay? So because we're subtracting 4AC, that's what it says right here, right? It says minus 4AC. So that's why we have minus, right? This minus sign right here, minus negative 1248. So that's been one step that might give you guys some trouble, but if you just follow the procedure I've been giving you, hopefully it won't be a thing that trips you up. So the very next thing that we do is we combine those two numbers, right? We have minus a negative, right? And minus a negative means to add. So we would have 121 plus 1248, and that's underneath the square root. And then we divide all of this by 12. So now we have 11 plus or minus, and we have to add 1248 to 121. And that will give us the square root. Remember, that square root didn't go away yet. We have 1369. Okay, and then we're dividing all of that by 12. So this next step is going to be where we have to get our square root, right? We have to find the square root of 1369. So we would try to go calculate that. And again, depending how your calculator works, you may or may not get this value. And so if you cannot get the value that I'm finding here, that would be a good sign that your calculator is not working. Okay, but the square root of 1369 is 37. So that means we have to do plus or minus 37. Okay, again, now the square root goes away because we've evaluated the square root, right? The value of the square root of 1369 is 37. And so now we have this all over 12. So now 11 plus 37 divided by 12, or we have to do 11 minus 37. So we have two different calculations that we have to carry out. So we'll do those two calculations, and then we'll try to simplify the fractions at the end. So the next line that we would have would be 11 plus 37, which makes 48. 48 divided by 12, or in this case, we will end up with 11 minus 37, which would give us negative 26 over 12. So at this point, we have to simplify these two fractions, right? We should see that 48 over 12 breaks down into 4. But we're also going to have to break down negative 26 over 12, right? And so we'd have to see that both of these values are even, right? 26 is even and 12 is even. So I know I could at least divide those both by 2. So that would give us the idea that on top of this fraction, we have 2 times negative 13. And on the bottom of this fraction, we have 2 times 6. So we can cancel out the 2's, and that would mean that we have negative 13 over 6 for our final answer. So the two answers we should get in this case are 4 or negative 13 over 6. Again, 13 is a prime number, so I know there's nothing else that I can factor out for me, right? So this would be done. So this problem will be finished at this point, and you'd move on to the next one. But of course, this would be a good time to, maybe check your work and go through and make sure you do this, okay? And this isn't always possible. Maybe on this test on Wednesday you run out of time, in which case you got to just live with the mistakes you have and just keep moving on to the next problem. But we could check our work by taking this value of 4 and plugging it in here and seeing what we get, right? To remember that, what does it mean to solve a quadratic formula, right? What does it mean to solve this problem? So we could go check right now to see that this actually does solve our problem, right? If I was to plug in 4, then that would mean that I have to do 6 times 4 squared minus 11 times 4 minus 52, and that would give me 0. Okay, and then we should realize, well, wait a minute, 4 squared is 16, so this means 6 times 16, and then I have to do minus 4 times 11, so that's minus 44, and then this is minus 52, so we're going to check to see if this is equal to 0, right? So in this case, this is kind of like what I call the question mark equals. We want to test to see if this is really true, right? We'll see if this is actually the case, right? So if we do 6 times 16, we get 96. So we want to check to see if 96 minus 44 minus 52 is really equal to 0. So you could do that. 96 minus 44 makes 52, right? So 96 minus 44 is 52, and 52 minus 52 is equal to 0, right? So in this case, we've kind of resolved our question mark equals, we know that it is true. And so since this is true, right, because we end up with something that looks like 0 equals 0, we are complete. And we have this idea that our our number 4 was actually a good solution to this problem. So that's what we're doing here, right? We're trying to find numbers that if I plug them into this equation, will make it equal to 0. So keep that in mind as we're solving these, all right? I told you guys you have the answers to the odd ones, so I'll be working on the even ones. All right, so let's go ahead and wrap up number 4 in this case. So we would check step 0. This equation is set equal to 0, so we'll leave it like that. That's fine. And now we go to step 1 where we copy the formula. So we set our variable equal to negative b plus or minus the square root of b squared minus 4ac, everything divided by 2a. Okay, that step is complete. So now we will go calculate the value of a, b, and c. And I say calculate, but really we just have to read it from the paper, right? And so 2 is a, right? Again, a symbolizes the coefficient of the quadratic term. In this case, b is also 2. And that's something that will happen every now and then. You'll have the same number in more than one location. And in this case, c is equal to negative 84. So we have negative 84 right here. Okay, so now then we have a, b, and c. We will copy everything else that we have, but we'll use blank parentheses to give us a place to go put these numbers. All right, so now here we go. We'll put 2 in this case, 2 here. A is 2, and C is negative 84, so we'll put that in this location, and again, we'll have 2 here, all right? This 84 doesn't really look good to me, so I'm going to do that again. Give myself a little more room to write it. So we have negative 84. Okay, so it's kind of helpful if your work is legible, so you can go back and see what happens if you get stuck on a problem. It's nice if you can see what you were actually writing. So again, we have negative 2. So in this case, this is going to stay negative. Okay, that's just going to be negative 2 now. So we drop the parentheses. Then we have 2 squared, and that's going to be 4. Then we'll put minus, and we'll put a blank set of parentheses, right? And as I mentioned to you guys earlier, we want to calculate the value of 4ac. So I've been noticing for some people to get this part done, you might even want to do this calculation in a separate place, okay? And then write the value of 4ac inside this parentheses here, right? So that's where we would go put that. So we'll go calculate that, right? We're going to get 4 times 2. 4 times 2 is 8, and 8 times negative 84 gives me negative 672. So we have negative 672 right here. So that would be the value that I go place inside this parentheses, is negative 672, because that's what 4ac is equal to, right? So now in this case, we finish up by dividing everything by 2 times 2. 2 times 2 is 4, so we get that. So now to simplify this, we are going to only change the part inside the parentheses, where now we have minus a negative, and so we're going to change that into plus 672, and then we'll put all of that over 4. So in this step, what we do here is we add those 2 numbers up, and in this case we have 676. So before we move on, we would try to go calculate the square root of 676. And as I said, depending how your calculator works, this might be a problem for you. So let me know if you can't figure out how to use your calculator. It's important that you know how to use it. But the square root of 76 is 676. Sorry, square root of 676 is 26. So we have negative 2 plus or minus 26, and then we divide them by 4. So we'll have to do those two calculations, right? We'll do negative 2 plus 26, and then we'll divide that by 4. Or we have the other value, the other possibility that we have negative 2 minus 26, and then we divide by 4. So now we'll work through and complete this problem. Okay, negative 2 plus 26 gives me 24 divided by 4. So that looks like that'll make a whole number. And in this next case, we get, don't forget to write or, right? We get negative 28 over 4. Okay, so when we do this calculation, 24 divided by 4 gives us 6. Or we have to do with the other possibility, right? 28 divided by 4 equals 7. So, sorry, negative 28 divided by 4 gives us negative 7. So we have two different possibilities, right? Either n is equal to 6 or negative 7. So this would be the way that you want your work to be laid out. Follow these steps. You want to be able to do these quick. If you feel like you need even more practice from this, please let me know. I could print out more practice for you. We'll be doing some examples in class, but this would be how you do number 4. All right, so now I'm going to go move on to the work on the back page. We'll do number 6 and number 8 to try to help you guys out so you guys can understand how to equation that is not set equal to 0. So we have to set it equal to 0 by subtracting 3 from both sides of the equation. After we subtract 3 from both sides, we want to be sure that we do our math correctly, right? We have 4 minus 3 equals 1, right? So that's the part that changes on the left-hand side, and everything's set equal to 0. So when I move to the next step, we copy the formula, and we get b equals negative b plus or minus the square root of b squared minus 4ac over 2a, all right? And I always say you can do the first two steps in any order, and in this case, you want to make sure that you do not forget what a, b, and c are, because now we're actually working with the new values that we have from this equation. All right, we're working with the equation that we have here. This is the one we want to solve because that's the one that's set equal to 0. So this is the one that we will use for the formula. So in this case, a is equal to 1, b is equal to negative 8, and c is equal to 1, not 4. So now the c is equal to 1. We equal that up. We put some blank parentheses. And there we go. All right, b is equal to negative 8. So we plug in negative 8 to both of those places for b. A is equal to 1, c is equal to 1, and since a is equal to 1, that's what we put in those locations. So now we finish this up. Negative 8 is positive 8, and then we have plus or minus square root of negative 8 squared, which is positive 64. And then we put minus, and we put one big blank parentheses there, right? So 4 times 1 gives us 4. So that's what's going to go into this location right here. It's just positive 4. 2 times 1 is 2. Okay, so as I was telling everybody in class today, like you may want to do the calculation of 4ac in a separate little area to make sure you don't mess it up when you're doing the rest of your work with the formula. But 4 times a times c means 4 times 1 times 1, and that's just equal to 4, right? So that's why we have only a positive 4 inside the parentheses. So now we'll continue our work. We get 8 plus or minus the square root of 60, and this is divided by 2. So what we want to do now is basically break down that square root and try to factor out any common factors so that we can break this number down all the way. So let's go take a look at the square root of 60 and see what we could get. Okay, 60 is there's a lot of ways to look at it. It's 6 times 10, right? And then you would just want to keep breaking down those numbers, right? And so if we think about it, 6 times 10, right, that's 3 times 2 times 2 times 5, right? So we have, like I said, 3 times 2 times 2 times 5, okay? And the only repeated factor that we see in here is 2. And because there's 2 2's, that means that we will be able to factor out a 2 from the square root, and they'll disappear from inside. So at this next step, we will move on, and we'll consider how that's going to change everything, right? So now I'm going to move our work up, and we'll finish up what we were doing. So at this step, what we have here is 8 plus or minus, okay, and again, because we had 2 2's, that means the 2 is coming out of the square root, but which numbers stay in, okay? What stayed inside there was 3 times 5, and 3 times 5 is 15, so we have a 15 inside of there, and we have a 2 on bottom. So we want to factor out a 2 from this expression, and what that means, like I said, we could do this a couple different ways, right? One way would be for us to factor out a 2 and realize that all of these expressions up here have a 2 in them, right? Obviously 2 is 2 times 1. This is 2 times the square root of 15. But 8 is 4 times 2, right? So what we could do is factor out a 2 from that expression. And we could say, well, this is equal to 2 times 4, right? Because 2 times 4 will give me 8. And we could leave the square root of 15 in here. Okay, so that we would get that value right there. And now we're dividing the whole thing by 2. So now we could cancel out the 2's and realize that all we have now is 4 plus or minus the square root of 15. So we would get 2 values, right? We would get 4 plus square root of 15, or we would have 4 minus the square root of 15. All right? That's one way that you could do this. I think the factoring out of numbers can be tricky, and people might see it one way. And so I'll try to show you guys a different way to do this last step. Okay? Another way to do it, we keep in mind that we're going to have to split these apart at some point anyway. So because we're doing plus or minus, and because both of these terms are being divided by 2, we could split this up into 2 numbers. We can make it 8 over 2 plus or minus 2 times the square, 4, I'm going to erase this part over here, okay, 2 root 15 over 2, there we go. So now we would see that here I could cancel out these 2's, because that's on top and bottom, okay, and 8 over 2 is really equal to 4, so this would be another way that you could simplify that, right? We could get 8 over 2 equals 4 plus or minus the square root of 15. And that's where you would get your 2 answers, as we said earlier, right? We'd get that it's 4 plus square root of 15, or 4 minus the square root of 15. All right? So there we go. That would be the way that you want to do number 6. Be careful to set this equation equal to 0 before you start working on it. Okay, so in this case we got an irreducible square root, and so notice that that's something that was supposed to happen on both 5 and 6. You're going to get a square root that you can't really reduce all of the way. You might be able to factor out one number like we did here. We were able to take out a 2. Okay, and again, when you have a repeated factor of 2, notice we get 1, 2 here, and then these ones from inside go away, right? They disappear, and the only ones that stay inside would be the lonely 3 and 5 that don't have a pair. They stay there, all right? So now what we'll do is go move on. We'll go take a look at number 8. So the first thing that we want to do here is subtract 3 from both sides so that we can set this equal to 0, as we call that step 0. Okay, so we have 11b squared plus 8b, okay, plus 11. So we can see that in this case, A is equal to 11, B is equal to 8, and C is also equal to 11. So that's a coincidence in this case, and that's what we got to use. So again, notice that we use the A, B, and C from this new equation that we created here. And then we'll get V equals negative B plus or minus the square root of B squared minus 4AC, and everything is divided by 2A. So now what we're going to do is go put some blank parentheses in here. And there we go. B is equal to 8. So we plug in 8 to these two places for B. A is equal to 11 and C is equal to 11. So I'll put that there. And A in this case is 11. So I'll also put that there. So now as we work through this, we will continue to simplify this expression. And that means that we will have negative 8 plus or minus the square root. 8 squared is 64. So we'll have that in this spot. And then we write minus and a blank parentheses. Okay, 2 times 11 is 22. So in that blank parentheses, we will go put 4AC. So let's go get 4AC. Okay, 4AC means 4 times 11. And 4 times 11 is 44. And 44 times 11 gives us 484. So the number that I will write inside that parentheses is positive 484. Okay, and you can see that we don't have a double negative this time. So the sign will not be changing. So now we go equals. We have negative 8 plus or minus. And now what we're going to do is add 64 to 484. And that gives us the square root. Sorry, in this case we're subtracting. So we'll do 64 minus 484, right? So be careful. I know sometimes we have to subtract the double negative and it turns into adding. But in this case, we just subtract, okay? So notice that in this case, we have a negative number. We have negative 420 inside of this parentheses. Inside of this square root. And here we have 22. So in this case, what we have to do now is try to break down that square root. But we also have to be aware that because that is a negative square root, we're going to have to factor out the imaginary number I from it. Okay? So we have to go break down 420. And after we do that, we'll keep in mind that we have the imaginary number I. We could do that in this step too. What we could do is pull out the imaginary number I and then change this value to now a positive 420, all right, square root of 420. And so now that's how you get rid of the negative inside the square root, is you'll have to account for that by using the imaginary number I. So we're going to go break the rest of that number down, square root of 420. So let's continue to do that, all right? I'll leave these steps right here for you guys to see. So to break up 420, you have to be persistent. I know these problems can be really unfamiliar at first because we're dealing with imaginary numbers, but you have to practice it one way or another to get used to it. So we want to break down again the 420. All right, we've talked about imaginary numbers for a while now. We've been using them in these quadratic formula problems. So what we want to do is, keep the I outside and notice that that's how we deal with the negative square root. Okay? Now we have to break down 420. And like I've been trying to tell you guys, breaking down a number, you just want to do that in shifts. You know what I mean? You could do it with a lot of writing and erasing or however you want to do it. But, 420, we could think of that, okay, that's 42 times 10, right? So just break it down any kind of way that you could think of. Okay, and then break down those numbers individually, right? Like 10 is 5 times 2, right? So you could erase that afterwards and think about it. Or you could just keep writing and put a bunch of steps, right? 42 is 6 times 7. So instead of writing 42, I'm going to write 6 times 7 right here, yeah? 6 times 7 times 5 times 2. But I see I can also break down to 6, right? 6 is equal to 3 times 2. So that means we have 3 times 2 times 7 right there. And so 3 times 2 times 7 times 5 times 2, right? And do any numbers pop up twice, right? We have a repeated factor. We have 2 and we have 2. So those would be the numbers that come out, and the ones that will stay inside are the ones that don't have a pair, right? We have 3 times 7 times 5. Those will stay inside. So we'll write equals -8 plus or minus. And because, again, there's 2 2's, right? We have this 2 and this 2, okay? We will factor out a 2 from the square root. Okay, the I is also outside of the square root. That's what let us change it from a negative square root to a positive square root. Okay, we wouldn't have been able to do that if we didn't use this imaginary number I right there. So now, what stays inside the square root? Right, what's still there? We have 3 times 7 times 5. So that's 21, right? 3 times 7 is 21, and 21 times 5 makes 105, right? So that's what we'll have inside the square root. Okay, there's nothing we could do to make that any smaller, and everything is divided by 22. So the problem is still not complete. You guys want to get used to, again, persevering through these problems. As we did earlier, we can see that there's a way that we can simplify these numbers, right, a little more by breaking them up into 2 pieces, right? We could do that this is -8 over 22 plus or minus 2I times the square root of 105, and that divided by 22 also. So we just broke that into 2 fractions, right? That one fraction got broken up into 2. So we'd want to continue breaking this down, right? So that we could finish the problem all the way and be able to see an answer that might be there, like on a multiple choice test. And if you're not used to breaking down a fraction like that, you know, these problems might get you. So let's break it down. -8 divided by 22. Well, as I told you guys earlier today, you want to try to recognize, hey, both of these numbers are even. So that means I can divide both of them by 2. All right, so I can show them in factored form, right? Like I can show that this is -4 times 2. And on bottom we have 11 times 2, right? So in this case, I can cancel out that 2, right? So now we change this number, -8 over 22, we change that into just 4 over 11, -4 over 11, right? So the next thing that we do is break down the other fraction, right? So we have plus or minus, and then we have 2I times the square root of 105, okay? And that's over 22, which is also equal to 2 times 11. So again, I can also cancel out these 2's, right? So those 2's will go away. And so that means that I'm left with the expression -4 over 11 plus or minus I times the square root of 105 divided by 11. Okay? We could even combine those back into one fraction now. However we wanted to express it, we have 2 different values, right? In this case, the last expression, we were able to turn one of the fractions into something that wasn't a fraction. But because both of these have the same denominator, it's probably the most convenient way to write it, right? So we would change this into -4 plus or minus I times the square root of 105 divided by 11. Both of them divided by 11, you see. So now we get our 2 answers, right? Our final answers would be -4 plus I times the square root of 105 divided by 11, or -4 minus I times the square root of 105 divided by 11. So when you're dealing with imaginary numbers, when you're dealing with negative square roots with a negative in the square root value, that tells you that you're going to have to use the imaginary number I. So get used to that. Anytime that you see a negative underneath the square root, That means you're going to have to factor out I, and then you can turn it into a positive square root and work from there. So, good luck working on the rest of this assignment. I gave you guys kind of a detailed process for the last 4 examples, so you guys can work on the other ones. I gave you guys the answers at least, so you should be able to kind of keep working until you get the correct answer. But there will be an example like each of these on the test that we'll be taking eventually. You'll have an example where there's an irreducible square root. You'll have an example where you have to deal with this imaginary number I, where you'll have something that's multiplied by I, okay? So hopefully you guys practice and are able to finish up this assignment. Otherwise, I'll point out this video to you to help you guys get it done. All right, good luck, everybody.